we will learn how to present this data or any sort of data in three dimensions. And for this, we are going to use some data, some drill hole data, okay, which have this downhole lithology information, okay, and other information of the depth, okay, and a dip and azimuth of these drill holes, and all this information we have in our in the CSV that I've shared with you. So if you haven't downloaded that data yet, you can download that data now. That is updated, and the same data we are going to use now. Okay, so we are going to install two plugins which are very important in this analysis: Geoscience and QGIS to 3JS plugin. Okay, this plugin will help us in converting our two-dimensional well-log data to three dimension. Okay, and this will help us in visualizing that three-dimensional data. Okay, so whoever deals with this drilling technique, it can be a geologist, it can be a hydrogeologist, it can be people working in oil and gas industry, mining industry, any industry. Okay, if you're working dealing with three-dimensional visualization and simple modeling of that data, then you can use these two plugins, and we will understand step-by-step process how to use these plugins in our analyzing our subsurface data. Okay, so first we will learn how to calculate what is desurvey data and how we can calculate it. Then we will calculate downhole geology, and then we will visualize this in 3D in 3D visualization. Okay, so now let's begin by first looking into the data that I provided you. Okay, so I have given you this Scholar, and there's geology, and there is survey data. So if I open all these Excel sheets, CSV sheets, let me open all of them. And there should be one more, surveys. Okay, yeah. So basically your Scholar data in drill hole refers to the starting point of the drill holes. Okay, starting point. It represents the starting point. So starting point, it of course it is located on the surface from where your drill hole begins. So the Scholar data coordinates. It provides the exact location where the drilling begins. For example, this and this. Okay, so I'm going to delete these coordinates, one of these coordinates here. Okay, yeah. So it gives us the depth. Okay, this is the depth of your drill hole. Like for example, it and the elevation we are taking as 0. Okay, so why 0? Because we are assuming that the elevation, uh, like wherever our Scholar is placed, okay, wherever our drill hole is starting, it is, we have taken that elevation as 0. Okay, and this is the depth up to which our drill hole, the drilling was conducted. Okay, these are the coordinates of these points, and this is your hole ID. Okay, so this is the data that we have. Now comes your geological information. So in geological information, if you will notice that so this is your hole ID. Okay, so this hole ID, it begins from the surface and it ends to the depth of your drilling. Okay, in between these are different lithology. Okay, these are different lithologies. This is cyst, and I think I forgot what the full form was. So whatever, they are different lithologies, okay, along the drill hole section. So this data is actually, it's from 0 to 80 meters. It is, the lithology is TS. From 80 meters to 150 meters, we are talking about the subsurface. Okay, so drill holes are made in subsurface. Okay, WDRD. And from 150 meters to 400 meters, it is, I think it was cyst. Okay, and 400 to 200 meters, some gneissic complex. Okay, some gneissic complex is there. So these are different lithologies exposed when drilling was conducted at this particular location. Okay, so in the same way, there are different drill holes and different lithologies are exposed at different depths. Okay, so this is the information that we have from our drill holes. Next data we have is for survey. So survey data in drill hole, it includes information about the deviation of the drill hole from its intended path. Okay, for example, we want to drill a hole that should be aligned perfectly 90 degrees. Okay, from top to the bottom, it should be aligned 90 degrees. So this is the dip of our drill hole. Okay, so sometimes what happens due to let's say hard rock or some other factors, we have to shift the uh, drill drilling at some particular angle. So here they provide this information of depth, how much there is a deviation in the drill hole angle, and okay, from 90 degrees. So this data is collected at various depths, okay, and include measurements such as azimuth, which gives us the direction, okay, and so direction is just 0 degree, just vertical, okay, and this is the angle of inclination, okay. So this is your the direction. For example, this is your zero, okay. So zero. For example, let's say it is north. Okay, so my drill hole didn't deviate from north and it went perfectly 90 degrees. Okay, and survey data like helps us in accurately mapping the drill holes 3D path. Okay, we have to see like how our drill hole went when we drilled a hole in subsurface. Okay, so this is the data that we require for today's analysis. Okay, so let's go back to our QGIS. I hope now you all are familiar with this particular window and you are much familiar with the interface now. So double click on the new empty project to start your project. Okay, so first, of course, in last few days, we didn't save our project at first because we were working in our previous projects. Okay, but today we are going to work in a new project. So let's first save our project. Okay, so I'll save my project in the folder that I want to work on. Okay, so I want to get this data 3D drill hole in QGIS. So I'll save my project here. Okay, so I'll name it as let's say 3D visualization. Okay, click on save. So I hope you all remember what is the benefit of saving our project. In browser panel, you get a project home from where you can just directly drag and drop your data, right? So this actually works with your raster data. This process do not work with the CSV files that have geometric information, that have the information of latitude and longitudes. Okay, it doesn't work with that. So what we have to do, what we can do from here, we can just drag and drop our raster file so that we know what is going to be our study area and where it is located. Because in this DEM, I do not know whether this is projected at correct location or not. Okay, so for that, I'm going to use another base map under XYZ tiles option, which can be my OpenStreetMap. Okay, so let's bring our DEM to the top. Okay, and this was the DEM that we created during our watershed delineation exercise. Okay, now comes our data that had this geographical information, that latitude and longitude information. Okay, so for that we have to use the traditional technique of loading CSV by going into data source manager, and there you will find delimited text option here. And using these three dots, you have to browse your data. Okay, so it was Kolar data that had this latitude longitude information. Okay, so here we have two coordinates values. Okay, so I'm just going to use first one. Okay, so because I deleted the second one, but I forgot to save it. So let me first save it, and then I'll refresh it here. I'll refresh it from here, and then let's load this again, and let's see if it is, yeah, now it has gone. Okay, so we just have one x coordinate and y coordinate now. So click on add and close. Okay, so let's bring it to the top, and this is how our data looks like. Okay, this is how our data uh, will overlap our DEM layer. Okay, but if you notice that other Excel, other CSV files do not have any latitude and longitude values. Okay, so how you will load it? So if you have any CSV that do not have any latitude longitude information, you can just drag and drop it. Okay, select both of them, just drag and drop it. Of course, they do not have any geographic information, so you won't be able to visualize it on your workspace. Okay, so to visualize anything on your workspace, you need latitude and longitude information in GIS. Okay, so now we have three data: Kolar data, geological information, and survey information. Okay, so now to make a map or make a visualization like this, we need a plugin. We need actually two plugins. So let's install those plugins by going into plugin and manage and install plugin. So sometimes when your internet is not connected, okay, so it may happen like you won't be able to see this all the plugins here. So for that, what you have to do, you have to go to settings. Okay, here you see it is showing me connected. Okay, sometimes it will show you not connected. So in that case, you just have to connect yourself with internet and reload your repository. Okay, yeah, let's go back to our all uh, the plugins. So first plugin I require is Geoscience. Okay, Geoscience plugin. Click on it, install this plugin. Okay, so for installing plugin, you need internet connectivity. Okay, so another plugin which helps us in 3D visualization of vector data or raster data in QGIS, that is QGIS 23JS. Okay, so this plugin, it helps you in 3D map visualization. Install this plugin. Okay, and after that, let's close it. Now, Geoscience plugin you will see in your menu toolbar. Okay, so now we have all this data, and Geoscience plugin have the option to manipulate our drilling data. Okay, so first we are going to desurvey our whole data. Okay, so basically this complete desurveying process is it helps us in calculating the geometry of a drill hole in three-dimensional space using the survey data. Okay, because Kolar data have this x coordinate and y coordinate, we require this information, and survey data have this dip and azimuth value. Okay, so when these two data are combined, then it helps us in calculating the geometry of a drill hole in three-dimensional space. Okay, so and here you see this is down dip is negative. Okay, but in our case it is positive, so we will untick this box. Okay, so if you have this negative value, then you have to tick this box. Okay, after that it will take all the factors, all the values automatically. You can just cross check, just check it once if all the things are correctly taken or not. Otherwise it will be fine every time. Okay, and if you want, you can increase this desurvey length, like we are going to keep it one only. After that, click on OK. Okay, will take few seconds. Yeah, you see there are two layers created. One GHK points Colar 3D. Okay, 3D points are created, and one GHK points Colar D surface. Okay, so if I close it, so these type of points are created. Now, what information we want? We want downhole data information. Okay, so we have created our drill holes. Now we want downhole data. So downhole data, from here, your desurveyed hole layer is your desurvey layer that we created, this one, and downhole data is there in your geological layer. Okay, and from here it will take the hole ID, it will compare the hole ID. Okay, and it will take from and to, depth from and up to depth. Okay, so this is the name of the layer that will be created. If you want, you can change it, and you have to select all of them. Okay, select all of them here. After that, click on OK. Okay, so this layer is created, geological layer. Okay, now because this geological layer, if I go to its layer styling panel, and if you will notice here, there are different type of geology, right? Different types of lithologies exposed in that drill hole. So we want it to be categorized in different with and represented by different colors. Okay, so what you can do, you will click on this layer which have geological information, downhole information, and then click on this layer styling panel. Okay, from single symbol, change it to categorized. Okay, so now which section or which column you want to use. So we can check here, and you will notice that we want to use the lithology layer to mark this mark the lithological changes. Okay, so value will be lithology, then click on classify. Okay, so these are the different lithologies. These are the unique lithologies that this column has taken. Okay, now if you want, you can change the line thickness. Otherwise, let's keep it this only for now. Okay, so I hope these two steps are clear with all of you. Okay, now this is your 3D information. Okay, and now I'm going to close everything for now. Okay, and I also want to add the this layer, watershed boundary layer. Okay, and let's see how we can use this layer for our analysis. So it should be somewhere here, I guess. Mm, 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 mm. Where is that drainage basin? Drainage basin, geo package. I think this is the one. I think so. Yes, this is the layer. Okay. So I'll make it transparent, and this is my DEM. Okay. I'll not open it right now. Now, because we have created all our data, okay, now it's time to make a 3D visualization of this data. So the plugin that we installed for it, you will find this under the web option. Okay, in this web option, you will find QGIS to 3JS exporter WebKit. Click on it, you will find such window. Okay, and before that, make sure your project is it is there, it is projected into some projected coordinate system. Okay, so the your project CRS should be a projected coordinate system. Here I have used the same CRS that we are using for our layers. Okay, that is 45 north. Okay, so otherwise your this 3D visualization window will give you one warning that change your coordinates to projected coordinate system. Okay, something like this you will get. Now let's start opening our files in this window. Okay, so my first will be my point layer. Okay, this is your one JHK point collars 3D. Okay, so these are the places where these drill holes were created. Okay, so let's start with the basic thing. So when you want to zoom to these any data in this particular window, you have to use your mouse scroll bar. Okay, zoom in, and for zooming in, you have to use your scroll bar towards your screen. Okay, and when you want to zoom out, you have to use the scroll bar away from the screen. Okay, it's very simple. And now if you want to move it in this way, okay, now if you want to move it in 3 dimension, so how I'm doing that? I am just I just click using the left mouse click button. Okay, and then hold it, keep pressing it and then move your mouse. Okay, so this will look something like this that you are able to see on my screen. And you will notice that there is change in this direction. Okay, you see, if you want, you can, if you double click on this center, okay, or if you double click on these XYZ directions, then it will change its directions as well. Okay, so you can do that as well. And otherwise, there is one more option when you want to zoom. Right click on the layer that you want to work with and zoom to layer. Okay. So this way, just left click and hold that left click and move your mouse. Okay. That's it. That's it you have to do. Okay. Now, so in your point geology, in your geological data, you have that geological information. Okay, you see, these are the drill holes. These are the drill hole information. If you will zoom in, you will be able to see that these are the different lithologies, along your drill holes that we measured when we drilled our hole up to 2000 meters. Okay, so but here it looks like the lollipops, right? So it has big head and very thin lines. Okay, so let's make it more visually appealing. So how we can do that? I'll go to geological layer, right click on it, go to properties. Okay, so here from line, change it to pipe. Okay, we'll keep everything as it is. Here you can change the radius, otherwise it won't look good. You see, this is very thick, right? So if you want to make it a little bit thinner, then you have to reduce its radius. Let's say I want to put as 100. Okay, click on apply. Now this looks better. Okay, click on OK. So there are other things as well. If you want, you can change them and see how it goes. Okay, apply and OK. Now let's change the size of these heads. Okay, these collars 3D. Again, go to properties, right click on the layer, go to properties. So if you want, you can change it to any of these things. Okay, so I'll keep it sphere only, but here I'm going to change the radius again to 100. Okay, then click on apply and click on OK. Now these drill holes look better. Okay, so because there are these are too many drill holes, so it is taking some time to process, okay, and to load. But don't worry, you can just zoom this to layer and you can visualize it in 3 dimension. Okay, so this is how your drill hole data, you can plot your drill hole data and make a visualization in your maps. Okay, now let's put our DEM as well. Okay, so maybe with drill DEM, it will take some more time to load. This is, so when it is processing, you will see this blue thing here. Okay, so this is your digital elevation model. Okay, and these are the drill holes. Okay, so in this view, you can see this. Now comes the vertical exaggeration. Okay, and what changes we can make into our DEM? You can go to its properties by right clicking. This is what we have already done. What if we do not clip this DEM? How it will look like? Okay, so yeah. So you see, this will have this white space and this is going to hide everything from our perspective. Okay, so I'll clip I'll keep this clipping with my drainage basin layer. And definitely you can put different colors. Okay, you can make different many changes in this visualization. It's all up to you. And click on OK. Okay. Now, yeah, there was one more thing. If you go to others, you can also build sides to it. Okay, you see this crisscross, no? So I think there will be some sides developed with this color. So that will look more better. Yeah, you see, you can change the color as well. Maybe this one. So you have to take this preview button here, okay? Then only you can have a preview of the work that you are doing in this. Okay, so you can choose any color. Okay, and yeah, so these, if you want to see your collars on the surface, so you can use this JHK point collars. Okay, so you can find that on the surface, like it will give you the location on surface. Okay, so wherever this drill hole was carried out. Okay, now yeah, see, you see, if you will notice that according to your area, the length of this drill hole is little bit less. Okay, so for that you can go to scene settings. Okay, and you can increase the vertical exaggeration. Let's say I'll increase the vertical exaggeration 10 times. Okay, I'll make it 10 times exaggerated. But all the things, whatever you have loaded, will increase 10 times, including your DEM. Okay, so it's taking some time. Okay, so right click and zoom to layer objects. Yeah, you see, everything is increased 10 times. Your drill hole, your D survey length, okay, and the elevation, digital elevation model. So everything increased up to 10 times. Okay, so you can decrease this value. Let's say you just want to keep it 2.5 times just to make your visualization look better. Okay, so this is what you can do with the 3D visualization of your data. You can plot earthquake points. Okay, if you are working in seismic section, you can plot and you can plot flood points. You can also for example, if you have any this layer, any polygon layer, so what you can do with your polygon layer, I close these two. We have plotted our point data. Okay, we have plotted our line data, the downhole geology. Okay, so what if you have some surface feature? Okay, so what if you have any surface feature? For example, if you have any river in this area. Okay, let me I think I do not have any polygon layer here. Let me search. Let me quickly search if I have any polygon layer or okay, let's create one polygon layer very quickly. So we had this, where is that river channel? Yeah, channel.geo package. Okay, so I'll put these lines here and I'll create some buffers around it. Let's yeah, just 50 meters buffer so that it looks like some polygon layer. Okay, so these are the polygon layers that we have. And now I want to plot this polygon layer here. Okay, so it will take some time to load. And you can apply the same for plotting the short point depth. Okay, in here, if you're working in the seismic field, okay, if you're working in the oil and gas area, then this sort of analysis, this sort of modeling is useful for you. Okay, so let me close this. Yeah, let's close this and whatever, and let's load it again so that it works quickly. And here, yeah, if you are also, if you want to show that that there is an area, if you have a digital surface model, digital terrain model of some area, and if you're working with the flood analysis, okay, if you want to show the impact of flood in the adjacent let's say settlements, then what you can do, you can extract the building data. Okay, so all the building polygons you can extract, and with those building polygons, you can create a buffer zone around your streams. Okay, and you can show that in 3D. Okay, so it looks like that this particular area is flooded. So you can create such visualization as well. Let's open these buffer. These, you see, right now these are plotting at the bottom. Okay, so I'll change the vertical exaggeration to 1 here. So if you had this type of layers, okay, you can, and if you have some building data in and around, then you can extrude those buildings, so it gives you an appearance of a model that is showing that buildings are submerged in this flooded water. Okay, so you can create such visualization with this 3D uh, this 3D very powerful 3D tool of GIS. Okay, so I'll go to its properties from polygon. So whenever you want your polygon layers to be shown as 3 dimension, you have to extrude it. Okay, so let's see if it works here. You see, if I'll see here, it looks extruded, right? You see, there is a slight increase in their elevation here. Okay, so in this way, you can extrude your polygon layer to show flooding in the area. Okay, if I put the channel along with it, so these are my river channels. Okay, and these buffer zones can be called as the flooded regions. Okay, so this is how you can represent your polygon point and line data. So what exactly you can do with your line data? Okay, you can, yeah, you can represent it with a thick line or, other things as well. Okay, you can use it as a pipe. Okay, you see, if you want to use this as a pipe, it will look something like this. Okay, so I hope you have understood what we were trying to, demonstrate here. Okay, now what if you want to export it? So just get a very nice preview of your data. For example, this Colar data I had, and I had this geological data in this drill hole. Okay, so we have to adjust this DEM, okay, in a way that all this information is clearly visible to us. Okay, for now, it is taking a lot of time. because I think the area is too big for processing. Yeah, in this way maybe. Okay. And if you want to show this base like this, okay, so it's moving too fast or too slow for me. Okay, but I hope you are getting my point, what I'm trying to say here. Let me zoom it out. Okay, let's raise it slightly. Yeah, like this maybe. Okay, I'll increase the vertical exaggeration to 2.5. Okay, so everything will be increased to 2.5 level. This DEM is actually taking a lot of time to load. So once it is loaded, what you can do, you can go to File, okay, and you can save this scene as image or GITF, okay. You can save it as image. Like if you want it for your projects, then you can save it as image. That's what I wanted to explain here because it is taking a lot of time to load. So yeah, like this. And now if you want, if you think that this is the perfect view for your data, then you can go to save scene as. Okay, let me close this. Okay, it is developing actually all the layers. You see, these are the spikes in the data. Spikes and the depressions, where we were talking about the depressions and all these things. Okay, and we do not want such type of spikes and such type of depressions when we are creating watershed basin. Okay, so that is why we need to fill up our DEA so that our elevation becomes smooth. These are the true elevation values. These are not the spikes, these are not the errors in the data. Okay, so now when we want to save this scene as image, okay, you can check the image width and height according to your requirements. Click on save and you can save it anywhere. Let's say in week 4, 3D visualization. On save. Okay, and let's go back to our folder. So this sort of images will be created. Okay, now and you can make them more beautiful, of course, right? You can make them more informative. Okay, now, so this is how you can make your 3D visualization. Now the next part here is to create the profiles, section profiles here. Okay, so for that I'm going to switch on all the layers again. Okay, I'll keep this buffer layer at the bottom because we do not require it now. Okay, now let's learn how to create the section or yeah, cross section across this profile and see this in a cross section view. Okay, so for that, go to Geoscience again, drilling, and go to section manager. Okay, so now you require your map canvas to create a section. You can also go with west east, south north, such sort of sections. Okay, but I'm going to use the map canvas option. Okay, after clicking on the map canvas, you will get this cross. Okay, this cross icon here. So wherever you want to create a profile, you have to how so it's important to understand how to create a profile. Okay, so make a first tick over the point, okay, or at the place from where you want to start your section. Okay, so just make a tick with your left click of your mouse. Okay, and then without releasing the mouse. Okay, without releasing the mouse, you have to pick all the points which comes in this straight line. Okay, you have to pick all the points. Okay, so you see only these 3 points are coming in, are intersecting this line. Okay, so once we are done with the with our section line, then only you have to release the left mouse click of so where okay, then only you have to release the left mouse click. Okay, just release the left mouse click. So as soon as you release, there will be a name of the section data, let's say profile 1. Okay, so this is our profile 1, and we require DEM. We do not require OpenStreetMap for this because this is our elevation raster. We also want to see the changes in elevation. Okay, and I do not want river to be included. I just want my geology to be included. Okay, so I'll untick this D survey. And yeah, of course, I also want my 3D collars information in it. So where my line is intersecting this point, I want that point as well. After that, click on OK. Okay, so this is my profile 1. Okay, now you see this is my section. Okay, so actually, but we tried picking up 3 points, but it only intersected with 1 point along that straight line. Okay, so this was the line, this was the point where it intersected. Okay, this was the first point. Okay, maybe in our zoomed in view, it appeared that all these points were intersected. Okay, so let's zoom this to layer, and you see here there is slight deviation. Okay, and here again it is not intersecting properly. Even here it is not intersecting properly. Okay, so you can take a line in which at least 2 to 3 lithologies are intersecting. Okay, so let's try creating a section along these 2 lithology one more time. Okay, I'll go to drilling and section manager. Okay, I'll just zoom in. I'll use my map canvas again, and I'll make a tick. Oops, sorry. Yeah, so this is not what we have to do. Section manager, use the map canvas, make a left click, do not release it. Okay, so like this and like this. Okay, so I hope we have intersected both the points. Okay, now I do not want this information, I do not want this information and this information in my cross section. So I'll click on OK, and let's say if it has worked. Yes, see, it has given us 2 points, 1 point and 2 point. Okay, and the lithologies in this particular under these 2 points. Okay, these 2 drill points. So this was our second profile. This is what we want to edit here. Okay, in this gives you the lithological information. Okay, so here again you have to select the lithology and classify it. Okay, so this is my classification. Now with all the lithologies, what you have to do, you have to increase the thickness, line thickness, so that it can be easily visible. Okay, so let's remove this. Yeah, it is taking this one only, right? Yeah, this is the layer. Okay, now let's increase the thickness to at least 2 points for all the layers, and simply you can do it from here as well. Okay, so let's find out the color. I think this is the color. Yeah. Okay. So these are different lithologies exposed along this particular area. This looks like something like this. Okay. And there is some purple color. Double click and increase the line thickness. No, this is not the one. I think it should be the one. Yeah. Okay. So in this way, you can change the colors of all these layers. Okay, this is it should be, I think, this one. No, not this. Let's increase this thickness as well. Okay, and this is yellow color, maybe this one. Okay, so this is how you can create your cross section profile. Now comes like where because this is not, that's not all we want to do here. We also want a proper section. Okay, proper cross section. Okay, so how you can do that? You have to take this to, you have to take this particular section to some other software like Corel Draw and Inkspace. Okay, and there you can connect these lithologies. For example, this lithology is connecting somewhere here. Okay, this is connecting somewhere here, this and this, and these two lithologies are connected here, but they do not have any relation. Okay, they are not, they are disconnected, they are not connected anywhere along this section. Okay, so you can leave it as it is, but you have to connect these two lithologies. Okay, I'll try to create this with line annotation here. Okay, so this is my annotation toolbar. So with line annotation, I'll try to connect it, these two lithologies here, like this. Okay, one, and also you can use your polygon as well. Okay, polygon annotation, I think that will be better. So with annotation you do not have any snapping option. Okay, so that's why we do not use annotation for digitizing. Okay, so like this you can create a polygon for this lithological section. Okay, right click to finish it. Okay, just give it the same color that we have used for lithology. And next connection will be with between this here and this. Okay, like this. And it's better if you take this particular section to some other softwares that helps you in creating the profiles. Okay, so you can take it to Inkspace, and you can also take it to Corel Draw to create your final profile section. Okay, so we have to leave these things as it is. This maybe it will correlate with some other point. Okay, so when you're creating different profiles, and if you are connecting them in 3 dimension, then only these will be created properly. Okay, and this is your elevation. This is the elevation variation in this area. Okay, so this is all about creating your 3D data, okay, in 3D modeling in QGIS, and visualizing it, and then how you can create the cross sections. Okay, so this is all from my side. So basically we started with loading our data, Collar data, and geological data and survey data. Okay, and we understood what these data is all about. And then and then after that, in QGIS we installed two plugins, Geoscience and QGIS to 3GS plugin. And in Geoscience plugin, so we started with Geoscience plugin. We required D survey hole. We calculated D survey holes, D survey data, and for D survey data we used Collar data and survey data. Okay, that we loaded using our CSV. And after this calculation, we also calculated downhole data. Okay, for downhole data, we need D-survey and geological information. After that, we used our QGIS to 3GS plugin to visualize this particular information in 3 dimension. Okay, and there we edited some of the properties of the points of the lines and the polygons to perform a proper 3D visualization. Okay, and then we learned how to export that 3D visualization, and finally we learned how to create a section of these 3 dimensional subsurface data. Okay, so today we dealt with all about the drill hole data. I hope this exercise will be useful for all of you when you are performing, when you are analyzing your own data, because 3D visualizations are quite useful when you want to see the 3D picture of some particular data. Okay, nowadays two dimension is not worth it, so you have to learn how you can visualize 3D data. Okay, so I hope this exercise will be useful, will be very beneficial for all of you, and this is all from my side now.